Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. In video 2, we're going to talk about functionality and limitations of the AKD Ethernet IP drive. Only the AKD motion tasking drive P and connectivity extension EI hardware model of the AKD supports Ethernet IP communications. The PCMM and PDMM support Ethernet IP, but this presentation and video series is specific to the single axis AKD drive with motion tasking. Note in the nomenclature below for connectivity, the EI is the only version of the AKD P that supports Ethernet IP communications. The list of functionality and access over Ethernet IP are as follows, but this is not an exhaustive list. Non-coordinated point-to-point moves, either relative or absolute, homing, jogging in velocity or position mode, enabling and disabling the axis, fault reset, reading faults, feedback position or other status, reading and writing to specific drive parameters, changing or operating in different op modes, torque, velocity, and position, perform a controlled or smooth stop, the dynamic mapping of drive parameters so they're included on the RPI scan, and more. It is important to understand that the AKD-P Ethernet IP drive is a motion tasking drive. Therefore, the drive's functionality available over Ethernet IP is based on its features and also has the same limitations. We are often asked what Ethernet IP masters we support. The Ethernet IP masters or controllers we have tested and officially support are exclusive to Allen Bradley. That is the MicroLogix 1400, Compact Logix, and Control Logix. Only the Compact Logix and Control Logix processors that use the RS Logix 5000 or Studio 5000 programming software support the addition and use of the AKD add-on instructions that we supply. These support fold I/O, cyclic, implicit communications as well as explicit communications via the MSG block. The MicroLogix 1400, which uses RS Logix 500 for programming, supports only explicit communications via the MSG block and cannot use the add-on instructions. The MicroLogix 1000 and SLC 505 Ethernet processors are not included in this list and will not work with the AKD Ethernet IP drive. We have not tested nor support the AV Micro 800 PLC family. What if my Ethernet IP is not Allen Bradley? Well, we have supported customers over the phone who use non-Allen Bradley PLCs and HMIs that were Ethernet IP capable. These include Omron, Automation Direct, and other PLCs, as well as HMIs like Proface. We did not have any documentation to share regarding the setup or any nuances or issues they experienced. We do have an application note that demonstrates the different command types supported as described in the Ethernet IP communication manual. While the PLC screenshots demonstrated using an Allen Bradley PLC, Compact Logix in this case, the methods are not Allen Bradley specific but part of the Ethernet IP protocol for the AKD. The intent is to demonstrate the methods at the core level which are not add-on instruction dependent. This application note helps to understand what bytes to write or read in the command and response assemblies over Ethernet IP in order to use these methods. This document is not currently on our website but is available on demand. There are some limitations to consider and keep in mind. The update rate. The AKD Ethernet port, that Ethernet IP uses as the communication interface can only process messages from the PLC every 20 milliseconds without Workbench and 40 milliseconds with Workbench. This generally is not a problem unless you are trying to do high cycle rate motion. If your application cycle time is faster than 20 milliseconds, then please consider the KES PCMM PDMM platform instead of the motion tasking drive. Non-deterministic. The AKD Ethernet IP is a non-deterministic field bus. So if you will want or need determinism, you will need to consider our KES PCMM PDMM platform or other EtherCAT controllers and the use of the AKD EtherCAT drives as slaves. Execution time. Keep in mind some functions take longer to execute than others. The enable, for example, may take upwards of 300 to 350 milliseconds to complete. Only one add-on instruction per axis can execute at a time. Later in this series, we'll elaborate and explain why this is a restriction. The AKD Ethernet IP drive is set up as a generic Ethernet module in the Allen Bradley, which means it does not use nor have the capability of SIP motion. However, it does not require the more expensive motion-ready processor models, so it can be a cost savings. Coordinated motion between axes are not possible over Ethernet IP. This means you can start two axes at the same time in your PLC ladder, but we cannot guarantee synchronism. In some cases, this can be resolved by commanding a master AKD drive over Ethernet IP, but using hardwired electronic gearing to achieve synchronism. Otherwise, consider moving to the KES PCMM PDMM platform and or AKD EtherCAT drives. Changing the move profile on the fly or the blending of moves is not possible over Ethernet IP. The intent is to move point to point and not command another move until the current move finishes execution. However, it is possible to set up predefined motion tasks in the AKD to blend into each other, but this does not use the AKD move block. Instead, it uses the AKD start motion task and AKD set motion task add-on instructions to perform this task. We will cover this in more detail later in this video series. S-curve acceleration is also not possible over Ethernet IP. It is possible to set up the S-curve for a predefined motion task in the AKD, but the S-curve profiling is done in the drive, not over Ethernet IP. Likewise, registration moves must also be done as predefined moves in the AKD.